One of the biggest questions that's plagued woodworkers from the beginning of time is how do you know that your combi square is actually accurate? Let's have a look. Welcome back to the Woodgrafter. A few weeks ago, Ralph over at Benchdogs kindly sent me over his latest offering, the Combi Max 45, a 45 degree, 90 degree combi square. And obviously, I'm going to do a review of this product sometime in the future. Equally, I've also got hold of the Woodpeckers Indexable, another 45 degree square. And both of these are going to be reviewed, and I'll also do a head-to-head on those to see how they compare with each other. But that got me thinking, how can I possibly check the accuracy of the 45 degrees on this? And some research tells me that the wisdom is you measure it. But although I've got quite a few products that have got 45 degree angles on them, and each of these products claim to be the world's best thing in accuracy, I have no idea. I've never checked them. So the danger I've got is I'm checking a 45 with a device that may or may not be 45 and claiming success. So I wanted to do something a bit better than that. So I went back to some basic mathematics, some schoolboy mathematics, and I had a look at things like Theales theorem and Isosceles triangles, etc, etc. And I think there's a way we can use applied mathematics to check the accuracy of our 45. But don't panic, we're not going to have a maths lesson. There'll be no numbers and no maths and no calculations involved. We're just going to draw some lines and then look at the accuracy of the lines. So in this video, we're going to look at the basic equipment that we're going to use. We're then going to create ourselves a board that allows us to measure the accuracy of these devices. We'll then put these through the paces. We'll see how we get on. I may not do all of them, but it's worthwhile having a look at a few different types of products, I think. And then if you are interested, I'll run through the maths so you can understand why I think this is a good idea, why it works. And that'll be pretty much the video done. Now, if this technique actually works, go ahead and share the video. Let's get as many people to see the technique as possible, because I do think it's a valuable one for the woodworking community. And I'm going to brand this one. I'm going to call it the Woodgrafter's method of checking the accuracy of your combi square for people who don't do maths so good. Catchy name, I know, but you heard it here first. So let's crack on and look at the equipment we're going to need to check these things. So the first thing is we need something to check, and I've got a variety of devices here. I've also got the new Combi Max 45 from Benchdogs. I've also got the 45 Indexable from Woodpeckers. I've got the two go-to tools I've always used in the past, my steric combi and my small steric combi. I've also got my angle finder, and I'd love to know whether this sort of cheap digital device are accurate or not, so we'll give that a look at as well. I've then got the precision triangle, again from Benchdogs, and I've got the cheap and cheerful, cost me less than £10, $10 from my local big box store many years ago. And this is the one that gets used on the field when I don't really care about accuracy. It just allows me to create a set distance. It allows me to approximate 90 degrees and 45. And I've never really considered this a precision tool, but having said that, I've never checked that one either. So we've got some tools that we know we're going to measure the accuracy of. And we may not do all of them in this video, because that would make quite a lengthy thing. Now I've also got a board, and it doesn't matter whether this board is square or not, but it does matter that I've got a known straight edge, and this is obviously a man-made board. It's a shelf out of a cupboard, and it's got this really nice plastic lip on it here that just shows that's straight. But we can check that for straightness, not squareness, just to bring up a known straight edge and just check that that is actually indeed straight, and it is. We're then going to need some sort of compass, and this is a high precision adjustable compass that also conveniently takes a pencil, as well as having scribe points that I use in layout. We need a pencil. Now ideally, the more precision you have in your pencil, the better, and this 0.5 millimeters would be ideal, but you wouldn't be able to see the lines on that one. So I'm compromising a little bit and using my laying out pencil, but I've sharpened it to quite a good point. Now, because I'm going to use so many devices, I've also got some A4 white paper and some painter's tape. So let me lay out the board and then we can get into some testing. Now, although this is a known flat edge, I just want to create a reference line parallel to that edge. So I'll just come in with my Benchdogs combi square, and just scribe a reference line down the board. So I've now got the reference line that's parallel to this edge. I'm going to keep sharpening my pencil as I go through. This is a very, very soft lead, so I'm going to keep just sharpening the pencil as I go through. Now the next thing I want to do is just make a reference mark here that's going to be my approximate centre line. It doesn't need to be square to anything, but I just want a reference point there. So I've dropped my pencil into my compasses, and I'm just going to draw a semicircle from that reference point at an appropriate size. Now what I mean by appropriate size, if you look at the Woodpeckers combi, it's got a very, very long rule on this. It's a 600mm rule. But if I look at my small sterret, it's got a small rule on it. So if I was going to measure the smaller one, the sterret small rule here, the 150mm one, I would want a circle that's less in diameter than the end point of that 45, if that makes sense. So drawing a circle that big is pointless. I'd need a circle this sort of big. So the short of these looks like it's going to be the Benchdogs one, so we'll have a diameter that's somewhere around about there. So we'll set our calipers to about that point there. 1, 2, 3, 4, 5. I've got 6 devices I want to measure, so I'm just going to stick 6 bits of paper on that. And the reason I want to put 6 pieces of paper here is so I can have a different piece of paper per device, otherwise it's going to get very messy on my board. And these have not got to be square, they've just got to be over that point that we made and stuck to the board. I'm then going to bring in my compass, and I'm going to put my compass directly on that point that we made, that reference point that we made before. So right in the middle of that reference point. And I'm going to make a circle. Or a semicircle. And while I'm here, I'm going to make that on each of my bits of paper. Come back into exactly the same hole. And that's just to prevent the compass moving while I'm not using it, so trying to reduce inaccuracies. And obviously the other great thing about white paper is that you can see it on the camera. So I've now got 6 semicircles on my paper here, all the same, all looking good. So what we're going to do, we're going to come in with the Benchdogs first of all. So I'll just put BD up here so I know. And we're going to come in to the point where the end of my semicircle intersects the reference line that we've drawn. So something like that. And then we'll draw a 45-degree angle up through the semicircle to where it intersects the circle itself. We'll then turn it over, we'll do exactly the same, but now we'll work on this intersection point, the end of the circle and the reference line, and we'll draw another line up to where that line intersects the circle. Now if this is truly 45 degrees, both those lines should intersect at exactly the same point on the circle. If the intersection of the lines is higher than the circle or lower than the circle, this is not 45 degrees. Now when you're doing this sort of work, in fact any laying out work, use your pencil to give you accuracy on your line. So put the point of your pencil on that intersection point and then carefully slide up the ruler to that point, and now you know you're directly on that intersection. And now I can come through and make that point like so. So I've now got a 45-degree line according to my Benchdogs square. I'm now going to come back in and do the same thing here. So I'm putting my pencil on the intersection point, bringing up the rule to that intersection point, it just touches, and then I'm going to draw that line as well. And in theory, they should all intersect on that line. And they do. So on the Benchdogs rule, this 45-degree line, and this 45-degree line, and my circle are all intersecting at the same point. In fact, those two lines are intersecting the circle directly in the centre of the line. So that is pretty good. What I now want to do is to check the 90 degrees. If I go from that centre point that we made in our circle and put my pencil in there and bring up that, this line should also intersect those two lines on that circle. And it does. So I now know that on my Benchdogs combi, these 45-degree angles here are indeed 45, and this angle here is indeed 90 degrees. So this square there is accurate. And it's that easy. I mean, the maths behind it is somewhat complicated, but the technique and the applied use of that is that simple. Sharpening my pencil again. So I know that my Benchdogs combi square is accurate. Hurrah! And I want to come in with the next one. And we'll now come in with my Sterret. Exactly the same technique. Bring my rule up to my line and draw my line. Turn it round onto the intersect point again. Draw my line. And now I'm going to come in with my 90 degree and draw my line. Now this is really interesting. My lines have intersected outside the circle. All three lines have intersected, which shows me that the 90 degree is actually good. So I know it's good at 90 degrees, but the 45 have intersected beyond the line. So this is showing me that the 45 degrees on my Sterret square is not 45. It's somewhat outside of the circle. This angle is probably greater than 45 degrees because it's outside the circle. If it was inside the circle, this angle will be less than 45 degrees. So my Sterret has actually failed our test. Interesting, very interesting. And now I want to come in with probably the most expensive tool in the shop and do the same test. So again, I'm going to come into the intersect point there and draw my line. Sorry, when you're doing this, make sure you're pushing down on the paper so the paper's flat if you're using paper. Into the other side, into my intersect line, and bring that down. And then I'm going to bring in, sorry, just I didn't go beyond the circle, I do apologise. And then I'm going to bring in a 90 degree and bring that down. And this is the woodpeckers. So on the woodpeckers, that again is bang on. All three lines are intersecting directly in the centre of my circle. So that is also a good pass and an accurate device. Now this could be interesting. This now is my cheap and cheerful. So this is a no brand device at all. And again, we'll use exactly the same technique. And there you go. And this time you can clearly see, we've got a fail, but this time you can see where the two lines intersect, it's way underneath the circle. So this angle is reading somewhat less than 45 degrees. And the centre point isn't quite intersecting the line, it's slightly to the right of the line, only marginally, but that is showing me that this is slightly higher than 90 degrees. So my no brand cheap and cheerful throw it in the toolbox and kick it around the floor device, this is slightly less than 45 degrees, and this is slightly higher than 90 degrees in some way, shape or form. So that device for accuracy is also failed. I want to have a quick look at the precision triangle, and I think I made the circle the wrong size. This is what I mean by make your circle commensurate with your device you want to measure. But I might just get it. So I'll come in with my pencil on the line, and I drew up right to the end of the line there, and interestingly they're actually intersecting slightly under the line as well. So I'll probably draw a smaller circle and recheck that one, but an initial thing shows it's probably failing. It's looking like this angle here is slightly less than the 45 degrees. The 90 degrees is good because it's intersecting the two lines where they intersect, so 90 degrees is good, but this 45 degrees looks like it's out. I now want to come in with my digital gauge, my angle finder. Now this is going to be slightly different. So we'll turn it on first of all, zero that down, and I'm going to set it first of all for an angle of 45 degrees, and if I can, yeah I can, and I'll come in onto that line again and make my line. Now obviously I can't flip this over, but it's a digital angle, right? So in theory, if I now move this to the 90 point, make that mark, And now I take this, and if I add 45 degrees to 90, which is 135, this is quite tricky because the blades are so thin, so there's not a big reference edge, but I think I've got it. Cool. So this is now 90, 45 and 45. And that's really interesting. So the two 45 degrees on this have actually intersected perfectly on the arc of the line. But the 90 degrees is slightly over. So when this was reading 90 degrees, it was actually more than 90 degrees. It was slightly over, which is very interesting. To be fair, this does have an accuracy claim plus or minus 0.2 degrees, so it's probably in tolerance for the device, but it's not accurate. So I'm going to call that a fail as well. So I've got two devices that are accurate in both the 90 and the 45 degrees. I've got one device that's accurate in the 90 degrees, but not the 45 degrees. I've got another device here that's accurate in the 45 degrees, but not the 90 degrees. And I've got a device that's not accurate anywhere, and a device I want to recheck. So there you go. There's a technique you can use to check the accuracy of your combi square, both the 45 and the 90 degrees of your combi square. And obviously, if you wanted to, you could check this at different points across that using that same technique, and then you know you've got an accurate device. And it's important that you do have a device in your workshop that you trust. And interestingly, the two devices I've relied on to set up my tools, 45 degree tools, aren't accurate at the 45 degree. But luckily, I now have a new tool in the shop that is good. So that gives you the technique, and if that's all you wanted, you can log off now, and thank you for watching, and I'll see you next time on the Woodgrafter. If you want to stick around, I want to explain the math a little bit as I understand it. I'm sure there's mathematicians out there who will laugh and ridicule me, and we'll all learn together. But let me quickly take you through the math so you understand how this works. Now I've just cleaned our board down here, and I've just re-put our reference line in, and I've just remade a circle, or part of a circle, from a centre point, which is there. Now the first theorem I'm using is a theorem known as Theales, or Theales theorem. Now what Theales theorem is saying to us, if we draw a line inside a circle from point A to point B, and that line AB is the diameter of the circle, which ours is because it goes through the centre point of the circle, then if you draw lines from point A to a position where it touches the outside edge of the circle, and you draw a line from point B till it touches the outside edge of the circle at the same point, then where those lines join, that makes an angle of 90 degrees. And it doesn't matter what angle A and what angle B are, if you do that, you are always going to have a line, an angle, sorry, of 90 degrees. So that's what Theales' theorem is basically saying to us. Now there's also the theory of isosceles triangles. And if you remember isosceles triangles, an isosceles triangle is a triangle where the length of two sides are equal. And if they're equal, then the angles of those sides as well to the base must also be equal. That's what an isosceles triangle says to us. So if I come in with a known 45 degree angle and draw those 45 degree angles at point A and point B, where they intersect should be 90 degrees. So Theales is telling me that that must always be 90 degrees, and Isosceles is telling me that because those two angles are equal, these lines here must be equal as well. Now when I draw my 90 degree line here from the centre to that intersect on that to the outside edge of the circle, what I've basically done is I've drawn the radius of the circle, and a radius is half the diameter. So this line here and this line here must also be equal in length. So if that's true, then this angle here and this angle here must also be equal. Now if we know that this is 45 degrees and this is 45 degrees, 45 plus 45 equals 90. We know that the total summation of angles in a triangle equals 180, so 180 minus 90 equals 90, which means that this angle here must be 90 degrees. If my test device is out in any way, these 45 degree angles will not intersect at the circle. There'll be a deviation, as we saw, above or below. And if the 90 degrees out here, this mathematical equation will tell me it won't intersect those lines at the edge of the circle. It will be out in some way, shape or form, left or right, that we saw. And that's it. So the maths isn't complicated. The explanation is probably more complicated than the mathematics. But that's what I'm applying here, and I think it makes logical sense to me. If you're a mathematician and you're really into this stuff, jump in and explain it better and correct any errors. But it makes perfect logical sense to me to apply those sort of theorems to this problem to prove the accuracy of my squares. And I know I've got two accurate devices in my shop, the Benchdogs and the Woodpeckers. Sadly this one's on loan, so it's going back, but this one is staying in the workshop, which is pretty awesome. So I hope you found this useful. I hope you find that technique useful. Nothing else to say. Take care of yourselves in the workshop. Have great fun checking the accuracy of your gear, and I'll see you next time on the Woodgrafter.